Okay. So this is the first question. You can see that what has been asked. Derive the Marshallian demand and the indirect utility function for the following preference. Okay. So now you see the utility function has the representation of this kind, where it's given in this kind of functional form. So this is nothing but multiplication of various xi's to the power alpha i's. So when I expand this notation, it becomes x1 to the power alpha 1, x2 to the power alpha 2, and so on till xn to the power alpha n. Fine. This is your utility function which has been given to you. Now there is a property which you must have gone through, which says that under monotonic transformations, the preference order remains the same. What this intuitively means is, when you do a monotonic transformation of this utility function u of x, then the order of preferences which was already there. So suppose apples was more preferred to oranges. So when you do the monotonic transformation of the utility function, then still apples will be more preferred to oranges. So what are monotonic transformations? So monotonic transformations are transformation of these utility functions which are strictly increasing. So suppose let's take a function log of x. Okay. So we know that the graph for log of x is of this kind. So we can see that this function is strictly increasing. So we can take a log transformation of this particular utility function. So when we do, the preference order will still remain the same. So let's take log on both the sides. Okay, once we have taken log, we can use the property of log. And let's assume this to be v of x now, where v of x is equal to log of u of x. And u of x was the original utility function that was given to us. So that implies v of x is equal to alpha 1 log x1 plus alpha 2 log x2 and so on till alpha n log xn. Okay. So in a compact manner, we can write this as summation of I ranging from 1 to n alpha I log xi. Now this is our transformed function. So the preference order, by preference order I mean this thing. I'll be I'll be pronouncing this as squiggle, which is how it is pronounced. So this is a squiggle. This represents a preference order. So a utility function is nothing but representation of these preferences. So u of x is a utility function that represents some preferences. V of x here is a monotonic transformation of this u of x. Fine. And so it represents the same squiggle. You don't need to get into the details. Just understand this, that under monotonic transformations, v of x is going to give you the same answers as u of x is going to give you. So for convenience and for computational purposes, we are just transforming it into log by taking log on both the sides and converting this multiplication into a summation. Okay. Now this is our objective function which we want to maximize. So this is a consumer's maximization exercise. Okay. In the question, it's not directly stated, but it's implicitly assumed that when consumers have some objective function, it's subject to a constraint which the consumers face in terms of budget constraint. So the budget constraint here is going to be where P1 to Pn are the prices of those commodities, commodities X1, X2, and Xn, and M is your income. So you are a consumer, you want to maximize your utility subject to this budget constraints where M is your income and P1 to Pn are the prices you face, which is not in your control but given by the market. And you are trying to optimize of what values of x1 to xn you should have such that the value of this v of x is maximum. So in a cookbook manner, the process is you formulate a Lagrangian and you write the objective function and you put the constraint, which is nothing but I'm writing a compact form right now. I'll expand it. So this is the Lagrangian formed for your consumers optimization problem. Consumers optimization problem. Fine. Okay. Now let's take the first order condition. So this is a very standard process in economics. You will see it as you move ahead and also when you move into your masters, that you formulate a Lagrangian and then you take the first order conditions, and those first order conditions give you some equations using which you move ahead and solve for the required thing. So taking the first order conditions, so suppose there are two commodities xi and xj. Okay, now when I write the Lagrange, one second. Yeah. Yeah. So suppose there are two commodities xi and xj. We have n commodities. We are taking two just for an example. Now when we expand this Lagrangian, it is alpha 1 log of x1 plus dot 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 alpha n log of xn plus lambda m minus p1 x1 to pn xn. Okay. This is the Lagrangian form. This is the expanded version. This one is the expanded version of this. There is nothing else. Now you take the first order conditions with respect to del xi, where xi is some good. And the answer you will get is alpha I by xi. This is equal to 0 implies lambda pi. So this is your first FOC. I will call the first order condition in short form as FOC. And you take some other good xj and you take the partial derivative of the Lagrangian with respect to that particular good. It will be xj by sorry alpha j by xj is equal to lambda pj. This is your second equation. Okay. These are the two FOCs you get. Now just divide 1 by 2 and you get alpha i by xi divided by alpha j by xj is equal to pi by pj. Okay. Now let's write one good in terms of the other good. So let's write xj is equal to pi by pj uh, into alpha I by alpha j into xi. Okay. Okay. This is a representation of xj as a function of xi. This is your FOC. This is the condition you have derived from your FOC, the equation 1 and equation 2. Now the budget constraint is sigma xi pi is equal to m. Okay. Okay, for simplification purpose, let's do one thing. Let's not write xj in terms of xi. Rather, I'll do one better technique. So learn how these techniques. So I first wrote in that form, but I'm having something in mind because of which I removed that thing, and now I'm reformulating it. Now these things are done for computational easiness, so that you don't get messed up in the algebra and you have clean solutions coming up. So let's write it in this form. Uh, we can write this thing as alpha I. One second. Yeah, so you can just do algebraic manipulation and you can convert this into this. Now the the reason why I did this is, so see, for any I and j, because I and j was arbitrary in that set of n goods. Arbitrary in the sense I just randomly picked two goods. These are not specific goods which I picked from those n. These are just any two arbitrary goods which I picked. So you can see that this ratio is going to be constant for all the n goods. And why you can see this, because for I and j, you see that this ratio is equal for both I and j. So let's assume some constant value k, which is the value of this ratio for all the n goods. So this is for I'll write, one second. Yeah, this is for every I comma j. This sign is for every sign. For every. You will study this in real analysis. This is a sign which is, it's a quantifier. So it's for every. इसका मतलब होता है कि n गुड्स हैं, सभी गुड्स के लिए जो उस कमोडिटी बास्केट में है, this equation is going to hold, and this ratio is having the value k. Now the advantage is, if you see here, pixi can directly be written as k into alpha I. Okay, and this is your budget constraint which we saw here. One second. Yeah, this is the budget constraint. Okay, so now you just substitute this thing here, and what you will get is, now in the question there is a condition already given that sigma of alpha I is equal to 1. When you do that, k can come out because k is a constant. So k is equal nothing but equal to m. That is your income. Okay. So this condition you get from here. Now again, see, pixi is equal to k into alpha I. This is something we have already derived. Then for k you just substitute is that equal to m, and you get, and then you can simplify to get, this is the Marshallian demand for good xi, and similarly it will be for all the i's in the set. So this is I belongs to the set 1 to n. There are n commodities. We just arbitrarily picked up I, and this functional form for the demand of I is going to be same for all the other commodities. So for example, x1 is going to be alpha 1 m by p1. Some x10 is going to be alpha 10 m by p10, and so on. So this is the Marshallian demand you derive for your consumers optimization problem. Okay. Okay. Now what have we been asked? We have to now compute the indirect utility function. Okay, so I'll just tell you a brief about what a indirect utility function is. So in a consumer's maximization problem, the standard technique is that you are given some utility function u of x, which is subject to some budget constraint. You solve this problem using the Lagrangian, which we just did, and you get some x1 star as the optimal demand for good x1. Okay, now this u of x, it's a vector and you have n goods x1, x2, xn. So x is a vector, it's a n tuple vector. Now when you expand, you can write it in this form. When you put the optima in this, what you get is the indirect utility function. But okay, Ankit, n tuple is nothing but I'll just tell you. So suppose there are n numbers and you arrange them in this form. So and name this something as A. So A will be called as a n tuple vector. So A belongs to Rn. I'll give you a simplified example. So suppose 1 comma 2 belongs to R2. So we call it a 2 tuple vector. And why is it a vector? Because you can plot it on Cartesian plane 1 comma 2. So similarly in n dimensions, there will be n components which we can't draw here, but it's called a n tuple vector. I hope this is clear. Okay. Yeah, so the commodity basket we have has n goods. So the utility function has n arguments inside it. By arguments, I mean these x1, x2 till xn. When you substitute the solution you got in the consumer's optimization problem in your utility function, so utility function that was given to us was sigma I 1 to n alpha I log xi. Okay, and for us xi, what we have derived as a result of the consumer's optimization problem is this. Now we substituting it here. So what we get is alpha 1 log of alpha 1 m by p1. And similarly for all you will do for all n, so you will get alpha n log of alpha n by pn. Now you can see that this I'm naming it as a indirect utility function. When you substitute for all the x stars, s- when you substitute for all the optima in your objective function, you get an indirect utility function. And why I have not mentioned anything inside the argument here is, you see, this v is a function of pi and m. So it's a function of the price and your income. So this is an important thing, that utility functions are functions of prices and income. So you can write v m comma pi as sigma I equal to 1 to n alpha I log alpha I m by pi. This is your indirect utility function. Is it clear to everyone? So we have derived the Marshallian demand and we have also derived the indirect utility representation for the particular utility function that was given to us, which is this. Can I proceed to the next question? You can just give a thumbs up so that I can follow up. Hello, am I audible? Can I proceed to the next question? Or if anybody has to ask anything, you can ask. Okay, so I'm because nobody is commenting on the chat, so I'll move to the next question, assuming that you have understood. So the technique used in this problem is a standard technique that has to be used in every consumer optimization problem. You formulate a Lagrangian using the objective function that has been given to you. Okay, I have a question. We choose the two arbitrary bundles so that we can find out. Yeah, the reason we are choosing two arbitrary, it's not, no, so see, the language you have used is not technically correct. It's not arbitrary bundles. There is just one bundle, x1 to xn. That's your commodity bundle. You are taking two goods out of it, which is xi and xj. Now the reason you are doing this because you want to show this equality. I'll just color it. You want to show that for any two arbitrary goods you take, this ratio is going to be equal to some constant which is k, and that is why you take two goods out of those out of that n tuple bundle, and the two goods are xi and xj. Is it fine, Harjot? Okay, I have one more question. No, you can't. Yeah, xi star can be directly put, and that no. So see, before transformation you can't do this because you transformed it in order for you to solve the consumer optimization problem. You formulated the Lagrangian, you took the first order conditions, you got the first order conditions, you had a budget constraint with you, then you used these two equations and then you solved for xi and xj. So you can't directly, because in starting before transformations, you won't have any xi star. You have to solve for that xi star first, and then you can substitute it in your utility function so that you get a indirect utility function. Why is the log not removed in the indirect utility function monitoring? No. See, the thing is that log is a monotonic function. It's a strictly increasing function, and there is a property that says when you do a strictly monotonic transformation of a utility function, the preference order which the utility function represents is going to be the same for the modified function also, the transformed function. So u was given to us, we transformed it by taking logs and we got v. So both u and v represents the same preference. By preference I mean this thing which I mentioned earlier. This is our preference. This preference gives you a ordering of what? So suppose you have n goods, you try to order it, which is the most preferred good, then which is the second most preferred good, which is the third most preferred good, and so on till which is the least preferred good. So this is an order. This order is represented by a utility function. So you don't need to get into the technical arguments and the technical knowledge of how this happens. Just take my words that this ordering which you have is represented by a utility function, and because there is some ordering, these this utility function gives some numbers to these things. so that you can arrange it. So suppose in x1 to xn, x1 is the highest preferred good, you assign a number 10 to it, and xn is the least preferred good, you assign 1 to it. So you can compare it, that 10 is greater than 1, so x1 is preferred over xn. So this is the thing, this is the meaning of preferences, and this preferences is being represented by utility function. And when you transform that utility function through a monotonic transformation, then you have the same preference order. Still x1 will be preferred over xn. Just that number will change. So 10 will become 20, and 1 will become 2, but 20 will still be greater than 2. This is the idea. Is it fine, Reyash? No, no, yeah, okay. Utility level will be different. But here you are, see, utility level will be different, but when you solve for the optimal function and when you substitute it back, that thing will be gone. It won't matter because of the monotonic transformation. It's just an ordering thing. Okay. Yes, yes, you can do this. This is, I am answering Navya. You can do it. Uh, you can solve for xi star, and you can directly put it into u of x. You can do that. That's absolutely fine. Without you have to do a monotonic transformation for ease of computation, but even if you don't want to do it and you're comfortable with the multiplicative form of the functional form, then you can go ahead. There is no issue. There is one question by Ankit. Sir, can you please explain the difference in technical terms, bundles and argument? See, I'll just tell you. So see, commodity bundle, if I have to define a commodity bundle, one second. So suppose there are n goods in the economy. Okay. So these n goods are x1, x2, x3, xn. So these are n goods. Okay. So this taken together, this whole n tuple vector, which I am naming as x, this is a bundle, and this belongs to Rn. Now, this just one good is an argument. It's an argument of the vector. So suppose if I have for simple case, if I take two goods, x1 and x2, I'll say that x is equal to x1 comma x2 belongs to R2. Okay, x1 is good 1 and x2 is good 2, and these belongs to this commodity space. This is a commodity space. So this is this complete thing is called a bundle, and this particular individual good in that bundle is called the argument of the vector x. Is it fine, Ankit? Okay, 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 guys. So we should move to the next question, I think. Yes, yes. Demand function will be same for both the utility functions. Yes, this is Sir's answer. So that is what I'm trying to say, that under monotonic transformations, nothing changes. You just do it for for the purpose of ease of computation. In layman terms, I mean informally, if you go into formal technical regarity, there are things that come into picture which you don't need to get into. For your purpose, you have to solve questions in the exam, and just take my words that you do this monotonic transformation like taking log for ease of computation, because you saw that we converted the multiplicative functional form to a summation functional form, and that helped us in the computations. So that is why we have done that. Okay, now let's move to the next question. One second. Okay, so this is question 3 from the problem set which I shared. Now this says that the consumer's preferences over two goods. So now we are in a two good world and not a n good world. Earlier we were in a n good world. Has the utility function which is this. Okay. Alpha I and beta i's are greater than 0 and these are constants. So I'll just tell you a few things which are important from an examination point of view. So generally what happens is in an exam environment we are very hurried and we'll only read this thing and we won't and we may miss this part, these things, or that these this is constant, alpha I and beta I are constant and both of these are greater than 0. So these are few details which we might miss in hurry. So it's very important for you to read each and every word of the question and understand it properly. I know the exam environment is a stressed environment and you have to be fast, but that comes with practice. When you do the problems in your home, try to read each word carefully so that you develop a habit of reading these words in the exams. It becomes a natural habit in your subconscious that you are going through each and every word of the question. So this is a very important condition for you to reach to the answer of this question. If you ignore this, you might end up coming to a wrong answer or you might end up not reaching to any answer. So you have to give emphasis on these conditions which are with the question, which is alpha I and beta is greater than 0 and both are constants. Okay, so now let's consider. So see, this is just a monotonic transformation. If you see it, you will realize that it's a monotonic transformation. Now so let's assume v of x1 x2 is equal to a into u of x1 comma x2. One second. A into log of ux plus b. So what have I done? For now, forget this, whatever has been given. Don't look at this. We know this, okay? And we know that under monotonic transformation, the preferences which u represents, the same preferences we will also represent, okay? So what I have done, u of x is some utility function given to you. I'm just taking a monotonic transformation of that function again. So when you substitute the function that has been given to you, you substituted this u of x here and then just use the property of log. Is this fine? Okay. Now you have been given a, now you look at this equation. You have been given some form which is a utility function. Now you are being asked for what value of gamma does this functional form that has been given represents the same preference as this. Okay, u of x1 comma x2 was given, v of x1 comma x2 has been given to us, and we are being asked for what value of gamma will these two utility function represent the same preferences. Okay, so let's do one thing. Let's equate the two functional forms. So we have gamma log x1 minus alpha 1 plus 1 minus gamma log x2 minus alpha 2, and that is equal to a beta 1 log of x1 minus alpha 1 plus a beta 2 log of x2 minus alpha 2 plus b. Okay. Is it fine for everyone? You guys can just comment in the chat so that I understand that you're following. Hello. Hello. Yeah. Ankit, I've removed the plus b. That's not required in the monotonic transformation. I'm sorry. I had written this as, so this term will be no more. There is no need of plus b. You can add it. The transformation you do has no changes, but there is no need here. So I'm removing it. Okay. Okay. So since you guys are okay, so now see what we have. If we have got this thing as a result. Now you see when you do the comparison on both the sides, you see gamma is nothing but a beta 1 and 1 minus gamma is a beta 2 because all other terms are same. Okay, so just by comparing, you can see that you can come to these two equations. Fine. Now let's add these two. I'm adding these two equations. So I get a is equal to 1 by beta 1 plus beta 2. Okay. And then you substitute this a here and you get gamma is equal to beta 1 by beta 1 plus beta 2. So this is that value of gamma. That makes v of x1 comma x2 represent the same reference as that is represented by u of x1 comma x2. So this is the first part of the question that we have answered. I think there are few. Harjot, is your doubt clear? I didn't see at that time. I have explained the monotonic transformation of the utility U. And we have this utility function given to us. I'm taking log on both the sides and I'm assuming this to be the utility representations after the monotonic transformation. So yeah, okay. So now it's clear to you. So and after doing that monotonic transformation, I have just equated the two. This is given to us, and this is something which we get through monotonic transformation, and I equate the two equations in order to compare them and get these two equations, and then I solve for a, and then I substitute that a back and I get the value of gamma, and that helps us to reach to this conclusion. Okay. Now this question has another part. Now in here we have to derive the Marshallian demand for the two goods when preferences are represented by this, assuming that the assuming the value of gamma has been found. So we have to assume our utility function now as, just one second, let me see what is the utility function. Yeah, it's gamma 1 log of x1 minus alpha 1 plus 1 minus gamma log of x2 minus alpha 2. Okay, so now we have to again do the we have to solve for the consumers optimization problem. So here, because there are two goods, so let's assume that the budget constraint here is going to be, it's not given in the question, but you have to take this in order to solve it. This is the budget constraint. Now let's formulate a Lagrangian. This is the cookbook approach. I am again repeating it. In any consumer optimization problem, you have to do the same thing. So we formulate a Lagrangian. Okay. Now, since you have formulated the Lagrangian, now take the first order condition with respect to the two goods you have. So doing it with respect to good 1 and equating it to 0, you get, this is the first order condition. Okay. And then you do it with respect to good 2 and you get, okay. So j- suppose I name this as 2 and this as 1. I'm dividing 1 by 2. What I get is gamma 1 by 1 minus gamma 1 x2 minus alpha 2 by x1 minus alpha 1 is equal to p1 by p2. This is your condition from FOC that you derived. Okay. The budget constraint that has already been given to you is this. Now from here, you solve x2 in terms of x1 or x1 in terms of x2. Okay. And when you do that, substitute. So suppose we solve x1 in terms of x2, we have to substitute it back here. You will have this complete equation in x2. Just do the algebraic manipulation and you will come to a functional form for x2 star. So when we do this, let me do it. So suppose I am writing x1 in form of x2. So gamma 1 by 1 minus gamma 1 x2 minus alpha 2 into p2 by p1 is equal to x1 minus alpha 1. So what I get is x1 is equal to alpha 1 plus gamma 1 by 1 minus gamma 1 p2 by p1 x2 minus alpha 2. Okay. This is what I got, x2 x1 as a function of x2. Now I'm substituting this x1 here. So p1 into alpha 1 plus gamma 1 by 1 minus gamma 1 p2 by p1 x2 minus alpha 2 plus p2 x2 is equal to m. Okay, now when you simplify it, this is what you get, this line, and you have to do further simplifications. So I'm not going into the messy algebra. I'll just write the answer that comes out. Okay, you guys can check it. The answer when you solve for x2 from this thing is alpha 2 gamma plus 1 minus gamma y minus p1 alpha 1 by p2. So this is the Marshallian demand for good x2. And similarly, you can solve it for x1. So once you have x2 star, you can substitute it back in this equation and you will get x1 star. Okay. So these represent the Marshallian demand for good x1 and good x2. Okay. So now please tell if you all of you have understood so that I can proceed. Uh, Y in the final answer is the income. Sorry. 1 second. I just this is not Y. This is M. Is it fine, sir? Now it's M, not Y. You represent income by both Y and M, so I just miswrote it. It's M. Okay, so since Navya is saying that she has understood, I assume all of you have understood. So we have derived the Marshallian demand, assuming that the value of gamma was known. Derive the Marshallian demand function for the two goods when preferences are represented by V of x1, x2, assuming value of gamma has been known. So we have derived it. So we can proceed to the next question. Okay, so this one is a bit conceptual and technical question. We'll take it afterwards. So let's do this question first. So one thing I have to tell. So if you see question 7 or question 6, so these questions have various parts to them. Okay. So in these sessions, what I have thought of is I won't be solving all the parts because some way these parts are interrelated. So if I solve one, I want you all to think on how to proceed for the other parts because that's important because in exam you have to go and apply things and this is a good time that you start applying what you learn in the classes. So that will be a good practice for you. So I won't solve each and every part. So for suppose question 7, I'll be solving the part 3, which I feel is a bit tricky and which does not come very naturally unless you have very much practice. So I will solve for 3, but 2 has the similar flavor. So you can think about 2. If you guys don't understand of means you if you guys don't get on how to solve even after several trials, then you can tell me in some other class. I'll tell you the solution. But for now, I'll only solve 3 in question 7 and you can try the others. So one is very trivial. So if you see one is very trivial, you just substitute rho equal to 1 and you get the indifference curve for the linear utility representation. Okay. So 2 is a bit tricky and is conceptual also, but has the same concept that is being used in part 3. So I'll solve part 3. So okay, now let's move on to the solution. So u of x that has been given to us is x1. This is the functional form for the utility function that has been given to us. Okay, and now we are being said that rho is tending to minus infinity. Okay, so one second. What I'll do is I'll use some properties here and I'll show you what those properties are. So see, the expanded version of it can be written as u of x1 comma x2. So this is a vector notation and this I am expanding it. Okay. So now let's do one thing. Let's take tx1 comma tx2 and let's substitute tx1 in place of x1 and tx2 in place of x2 everywhere. And then you solve it and then you will get what you will get is this. Okay. And you can write, so you see, now you must have studied this. This is homogeneity of degree 1. So this utility function is homogeneous of degree 1. Okay. So I've shown you how that is happening. And there is a property to homogeneous functions which says that for if u of x1 comma x2 is a homogeneous function in x1 and x2, then you can represent u of x1 comma x2 as x1 u of x1 by x2 comma 1. So what you are doing is you are taking x2 common. Sorry, one second, it will be x2 into u of x1 by x2 comma 1. Okay, so you have used the homogeneity property for homogeneous functions. Okay, so now let's proceed. So when we do this and apply this property in this functional form for the utility function, what we get is, so u of x that is given to us is now I'm taking out x2. Is it clear till now what I have done? I'm using the property for homogeneous functions. Okay, one second, I have a few comments. Okay, so you guys are understanding. Okay, so now let's take case 1. So see, why I said that this is not a question in which the process of solving is very natural, because see, the first thing that you have to use a homogeneous the property of a homogeneous function. This does not come very naturally unless you have solved many problems and you can see and identify that this is a constant elasticity of substitutions utility function, so it's going to be homogeneous. So by practicing and solving these kind of questions and keeping these properties in mind, and revising them before the exams, it will help you in order to recall back, and you can then use these properties in the exams directly. Because if you go to solve this question by any other approach, I think it will take you more than an hour. And using just the property of homogeneous function narrows down the solution to this problem to a 2 to 3 liner solution. So that is the way you have to start thinking gradually. I am not expecting that you think start right away, but when you do it again and again, and when you listen to the classes, Harjoti sir, the no, so see, this is homogeneity of degree 1. I have just taken t inside it, and then I am getting t to the power 1 here. So it's homogeneous of degree 1. Okay, not for all degrees. I hope I am clear, Harjot. Okay, so case 1 is, let's assume that x1 is greater than x2. Okay, so what we have, rho is tending to minus infinity. No, you can't use it. So yeah, in homogeneous functions it can happen that you get, so 1 second. So if you write this t, I'm just taking some other example. So Harjot has a question, he's asking that can the power of t be some other number except 1? So I'm answering that question. So suppose f is a homogeneous function, and when you take t inside and you get this, then we say that f is homogeneous of degree k. Okay, here f is some arbitrary function, we don't know the functional form. Here u has a functional form given to it, and when you do this exercise, what comes out is only t and not t square or 2t cube, because the functional form is already given to us, and what is coming out is just t and not t square and t cube or t to the power 4. So since only t is coming out, you have homogeneity of degree 1. Clear, Harjot? Okay, so it's clear to him. Okay, so yeah, see, I'm assuming a case here. Let's assume x1 is greater than x2. Okay, okay. So what will happen is u of x1 comma x2 is equal to x2 alpha 1 x1 by x2 to the power rho by alpha 2 1 by rho. And when you solve this ahead, it's u of x1 comma x2 by x2 is equal to alpha 1 x1 by x2 to the power rho alpha 2 1 by rho. And now since rho is going to minus infinity, we'll take the limits. We get this. Now see, x1 is greater than x2. Okay, since we have assumed that case, and x1 by x2 has been raised to some power of rho which is negative because it's going to negative infinity. So what you can write is 1 by x1 by x2 to the power rho, because rho here is negative, so you can have this form because rho is going to minus infinity. And since x1 is greater than x2, so some number greater than 1 reach to the power infinity. So let me write here. I'll Instead of rho, I'm writing minus infinity, okay, because rho is going to infinity. So what you can have is this thing, okay. So x1 by x2 is going to infinity, okay. So yeah, so something greater than 1 to the power infinity is going to be infinity. So when you do this and when you solve this limit, what you get is uh, u of x1 comma x2 by x2 is equal to uh, so this term becomes 0 because it's 1 by infinity form. So this term goes to 0, okay. 1 second. Uh, okay, okay, yeah. So see here also it's 1 to the power minus infinity because rho is going to minus infinity. So what you have is alpha 2 to the power minus 1 by infinity, and so you can write it becomes nothing but alpha 2 to the power 0 because 1 by infinity is nothing but 0, and 0 and minus 0 is the same thing, so it's 1. So what you have is u of x1 comma x2 by x2 is equal to 1, implies u of x1 comma x2 is equal to x2, okay. Now this is under the condition this that I've already assumed. X1 is greater than x2, and what you get is u of x1 comma x2 is x2. I have one question which I'll just look. No, rho is tending to minus infinity. Have I taken plus infinity anywhere? Here, this was the functional form. I converted it into this form because a to the power minus 2 is equal to 1 by a to the power 2. So that has been used. And then you get this by solving it. And so you come to this solution. And remember, this is under the condition that x1 is greater than x2. Okay. Now, when you take case 2, where you have x2 greater than x1, you do the same process. What you will get is u of x1 comma x2 will be equal to x1. So what you can summarize is u of x1 comma x2 is equal to x1 if x1 is less than x2, and x2 if x2 is less than x1. Okay, so what you can write it in compact form is u of x1 comma x2 is nothing but minimum of x1 comma x2. Yeah, so is the process clear? Okay, so two of you have given a thumbs up, so I think it's clear. Are you guys following it? You can comment if you don't understand any particular thing or any particular way in which I am explaining, because for me also this is the first time that I'm taking an online class. I've never done this before, so you can tell this. No, so Ankit has a question where he's asking that did you know beforehand that you have to arrive at these cases? So see, no, we don't know that we have to arrive at these cases. We are solving it from like the base, the what you say, the first principles. We have not assumed anything. We have used the concepts of homogeneous functions. One, we have used the concepts of limits, and we have used the concept of something constant to the power infinity or something constant to the power of 0. So it's this question does not have very much economic intuition into it. It definitely has if you go into the economic intuition, which is very important to understand. But from a solving standpoint, if you have been asked to show something that when rho tends to minus infinity, the constant elasticity of substitution preferences tend towards a Leontief utility preferences. So that is the process that has been used. You will get, you will learn these things gradually with time. So nothing is assumed beforehand that we have to arrive at such cases. What I have done is I have taken these cases. You need to take these cases. Why? Because when you come here and you start applying limits in the next step, here, then you need to know that whether x1 is greater than x2 or x2 is greater than x1. Because when you know that, only then you can use these things. I could use this thing here, because I knew that x1 is greater than x2. And because x1 is greater than x2, then x1 by x2 is going to be greater than equal to 1. And anything greater than 1 to the power infinity will always be infinity. And that gives these things here. So I have used the property of limits and basic logic, because of which you get these things and you come here. Okay, so Ankit is fine with the answer. Okay, so you have derived what was asked to you. You were asked to show this thing, and you can see that we have derived it. So this is not an easy question, in the sense that it requires two things which you need to use that does not come up naturally. One is the homogeneity of this utility function, and the other is taking these cases and then using the property of limits in order to solve this question. So similarly, you have to approach this question also. There will be slight differences, but you have to use concepts of limits and then you can solve it. Okay, so Navya has a question that how can we get in the second case u is equal to x1? So Navya, you see in case 1 we have x1 greater than x2, and when we solve everything, what we are getting in the end is u of x1 comma x2 is equal to x2. Okay, so similarly when x2 is greater than x1, so when you solve through a similar approach, which I will encourage you guys to do it, you will get this. Do exactly the same way I have done for the case 1, and what you will reach is u of x1 comma x2 is going to be x1. So that is the way u of x1 comma x2 is x1. I hope it's clear to Navya. Okay, good guys. Okay, so now we have solved this question also. So which questions are left? Let me see once. So this one is left, and okay, so this is a technical question. I don't think you need to go into the technical details, but still it's a very important property, and that is why This question is in the problem set. So the question says that in a lexicographic preference structure, this is what happens, that when there are two bundles. So let me go into detail of this a bit. There is one bundle X and there is some other bundle Y. And suppose you prefer X to Y. Okay. So lexicographic preference says that in a lexicographic preference, what you do is you compare the first arguments of the two bundles first. If X1 is greater than Y1, then you directly conclude that X is preferred over Y. Okay. But if X1 is equal to Y1, then you go to the second argument and you see whether X2 is preferred over Y2 or not. If this happens, then again you conclude that X is preferred over Y. Okay. So this is the lexicographic preference. So now let's see what this question asks. Can these preferences be represented by a utility function? So what does the question mean? So you have to understand first that what does the question exactly mean. So I'll not go into the technical rigority. Shreyash has a question. 1 second. Sir, in the second case, we have to take out x1 in order to solve. I didn't understand your question, Shreyash. Okay, so sir is telling me to give an example. So suppose x is 2 comma 5 and y is 1 comma 3. Okay, so here since 2 is greater than 1, then x is preferred over y. This is lexicographic preference. So suppose x would have been 2 comma 5 and y would have been 2 comma 4. So since first two arguments are the same, we go to the second argument and we see 5 is greater than 4, and hence we conclude that x is preferred over y. So this is an example which I can give you straightforward. Khushi has a question. Okay, so yeah, Khushi is giving me the answer. It's right, Khushi. So lexicographic preferences cannot be represented by utility functions because they violate the property of continuity. So I'll just give you a slight detail. You might need these details for exams like IIT JAM and ISI. For others, I don't think they will ask and go into so much of depth. So see, this is a preference order, as I mentioned earlier also. This represents a preference order. Now, this preference order has got some properties. The property of transitivity, the property of reflexivity, the property of completeness, and the property of continuity. And there are other properties also which you don't need to get into. So for a background, you just remember that any squiggle which represents a preference has these properties: transitivity, reflexivity, completeness, and continuity. Okay. So what continuity property of squiggle say? Since you guys have not covered real analysis right now, are you do you guys know about sequences? Okay, okay, I'll just connect. 1 second, I am getting a call. I'll just connect. Okay. So continuity of squiggle says that. So suppose uh, there are two bundles X and Y. Okay. So I'm assuming X to be X1n comma X2n and Y to be Y1n and Y2n. Okay. So what it is, I'll explain you exactly what does this mean. Just give me 1 second. So see what happens is, so this is your commodity space. Okay. So what I'm doing is, there is a comment, Navya Sharma. Okay. Yeah. So what happens is, I'm taking a sequence in this commodity space. That sequence is X and that sequence is Y. So these are two different sequences. Now, when you define a sequence X1n, what does it mean is, it's this. This is a sequence. This is a definition of a sequence. You will learn this in real analysis in a rigorous manner. For now, just take that n varies from 1 to infinity. This n here. Okay. So this is a sequence. When you take x is equal to x1n comma x2n, this is a sequence with two arguments in it. It not only has one argument but two arguments. So for when I vary n for different n's, what will this have the form? It will have x is equal to x11 x12 comma x21 x22 comma x31 x32 comma and so on. So this is also a sequence. Okay, this sequence is different. This sequence is different from this sequence only in the point that here the terms of the sequence are just one element. Here the terms of the sequence are not one element but a tuple of 2, size 2. Okay, so this is the difference. So suppose I take two sequences X, where x1n comma x2n, and then there is Y, where it's y1n and y2n, and I'm assuming some value. So suppose x1n comma x2n is such that it's a constant sequence. Sir has a comment. Yes, there should be a comma between these two. Okay, so I'm assuming a constant sequence x, for which the first argument is always a and the second argument is always 0, irrespective of what n you choose. So it's a comma 0, a comma 0, a comma 0, and so on. This is your sequence x. Okay, and for y, let's assume a functional form. Okay, where b is some positive number. So I'm assuming it, nothing has been given. I'm just showing you that the property of continuity will be violated. And for this is a standard proof which I'm writing, not very rigorously, but in a manner in which you can understand. I'm using the concept of sequences. So n represents a natural number. N belongs to the set of natural numbers. So n can vary from 1, 2 until infinity. Okay. Now you see when, so suppose the preferences are lexicographic. Okay, so what you do, you compare the first element. When you compare the first element in x and y, the first element in x is a and the first element in y is a minus 1 by n. So since n is always greater than 0, so we can clearly say that a is greater than a minus 1 by n. Okay, and hence what we can conclude is, so the xn should be preferred over yn. Okay, so first argument of any element in the sequence is a in xn, and first element of any term in the sequence yn is a minus 1 by n. So when you compare them, what you get is xn is preferred over yn for every n. Okay, this is the property of lexicographic preferences. I just gave an example here. This thing, I'm using the same thing just in a mathematical form. Okay, okay, so let's keep this. Now xn is a comma 0 and yn is a minus 1 by n comma b. Okay, so now let's take limit n tends to infinity for this sequence yn, and what you get is a minus 1 by infinity comma b. And for this you will still have a comma 0 because this is not varying with n. So what you get here is a comma b. Okay, because 1 by infinity will be 0. So x, which is the limit for the sequence xn, we have x is equal to a comma 0, y, which is the limit for sequence yn, so y is going to be a comma b. Okay, so now we have these two things, the limit of the sequence xn and the sequence yn, and now when you compare, you will see that the first argument is a and it's equal, but second argument is b and that is greater than 0. So what we conclude is y is preferred over x. Okay, so now let me tell, so suppose this is a sequence, okay, and this is going to some point, it's converging to this is a sequence, it has got infinite terms. For each of these terms, this is the sequence x and this is the sequence y, and this is also converging to some points x star, suppose. For every term, what you have is, so this is some xi and this is some yi. For this you have that xi is preferred over yi, but in the limit what you see is y is preferred over x. Okay, so this violates the property of continuity. What does the property of continuity say? It says that when xn is preferred over yn for every n, then in the limit x should be preferred over y. This property is formally said as squiggle is continuous. Okay, uh, but here what we see is xn is preferred over yn for every n, but y is preferred over x. So continuity is violated. And because continuity is violated, so this squiggle, which has a lexicographic preference, cannot be represented by a continuous utility function. Uh, is the solution clear? You guys comment, I'm coming in a minute. You comment, I'll just come and look into your comments. Just give me 1 minute. Yes, I am back. So, is the solution clear? You didn't comment anything. Navya says it's clear. Ankit Verma. Can we use the abbreviation in the paper for explanation? Uh, yes, I mean, see, this question will never be asked in exams. The important thing is the property of continuity. You might be asked just for a knowledge purpose that which property of a standard preference does a lexicographic preference violate. This is this I'm answering Ankit. He has a question that do we need he asks me that do we need to show all this rigority? First of all, you will never be asked this question for sure. Then why am I discussing at all? Because the fact that continuity is violated, and that is why you can't represent lexicographic preferences in form of utility functions. This is an important property which you are expected to know. This might be asked directly in IIT Jam in a MCQ form or the PEA paper of ISI. So these are important properties which you guys need to know. The proof is not very important for you, but I'm just giving the proof so that you have a flavor of how things are going to become technically more rigor as you move down the time and your exam approaches. So concepts from real analysis, limits, calculus, whatever you will learn in the mathematics classes will have a direct application in economics in the proofs you write during the exam prep or during the masters in whichever college you go. So these things are important. So Ankit is raising his hand. 1 second, I'll just unmute him.
Hello, sir. Am I audible?
Yes, you're audible.
Sir, my question was that if we have in the subjective paper the thinking
Yes.
process, how literally do we have to? For example, you use in the last line you written which LX does not mean that UX is continuous. So LX is lexicographic. I was
No, no, no,
asking
no,
you
no, no.
those
You
terms.
can't. You can't use these. See, I have a constraint of time in which I
Okay.
have to clear. I have to cover all questions. So I might use short forms somewhere. So, see, I'm using FN for functions. I'm using
Hmm.
LX for lexicographic. Similarly, I might have used some short forms anywhere. When you do classes more with me, you will get versed with the short forms I use, but you can't use these in the exam. In exam, you have to write everything very clearly, especially PEB papers are read very carefully. Every line and whatever you write has marks for it. So keep this in mind that whatever you write, the professors don't understand your abbreviation, and these are the ISI professors who check your copy. So even inside ISI, when you go and you use these short forms, you won't be given marks. So it's very important for you to be precise and clear whenever you write the answers. I am trying to be as much precise as possible, but I have a trade-off of time and the precision which I have to do. So that is why I'm using some short forms, but I don't encourage you to use the same. Okay.
Okay. Got it, sir. Thank you.
Okay. Okay. So this is an important question in the sense that it captures an important property. So lexicographic preferences do not are not continuous. So that is why they can't be represented by a utility function. So for a continuous representation of a utility function, you need all these four to hold. If any of these four doesn't hold, you can't have a utility representation. So before moving on to this question, the question that is left, this one, I can discuss one of the parts. I'll encourage you to do the rest. let me emphasize on an important point here. What happens is, see, if I have to explain you what is the intuitive link between preferences and utility, I explained it few minutes back, but I'm again explaining you because we have just done a question. So see, there is a there is a bundle, okay? So suppose there are n goods in it. You have to form a ranking order. Ranking order, by ranking order, what I mean? So suppose there are n goods. So x1 is the most preferred, x2 is second most preferred, and so on. If you go to xn, that is the least preferred. So this is the order in which you arrange that if I get a chance, I will choose x1 first. If I'm not given x1, then I will choose x2. If I'm not given x2, then I'll choose x3. If I'm not given any of the n minus 1 goods, then I will choose xn. So this is an order, okay? Now, this order needs to be represented by a number, because when you compute utilities, when you compute demands, and when you compute the values of these things, you have numbers there, okay? You don't have orders there. So there is a mapping from these orders to the set of real numbers. You must have, sir must have taught you this in the classes, that there is a map where you rank and then you convert that ranking into a number. So this is the link between preferences and utility. So that idea is being used, and that is a very important link which you need to understand, that what is the link between preferences and utility. If I go into the detail, then even 2 3 classes won't be sufficient to explain you, because it's a very broad topic and you will be explained all these things in technical regularity when you go into your master's classes. But for now, for the purpose of exam, what things are important, I'm just saying you those things. Okay, so go through these questions, whatever I have done, go through the technical parts of the solutions which I have introduced. If you find any doubt by watching the recording again or by going through the solution what I'm writing, you can ask these in the following classes. But try to start getting a hang of the technical regularity and the intuition behind all these things. That will help you in exam to solve the questions faster and with clarity, and that is very important. Okay, so let's move to the last question for the day. We'll solve this question. Okay, so this is a very conceptual question. I don't know how many of you could have how many of you have done this, but if I was given this question, maybe in starting of my preparation, I can surely say that I won't have been able to solve it. So let's see what is such that it this question I'm saying that it's a good question. So let's solve part B first. Okay, 1 second. Okay, so see what we have been given is there are two regimes. I'll write it, regimes, which is regime 0 and regime 1. Okay, what information we have for regime 0? Regime is nothing but a case. Okay, there are two cases, case 1 and case 2. More precisely, we call it regime and not cases. So that is why I'm using the word regime. So regime 0 says that the price vector for the two goods, so it's a two good world. You can see in the question starting they have mentioned the price vector is 1 comma 1. Your income is 8. Okay, and your bundle which you are consuming is 4 comma 4. So what does this mean? So let's plot this. That's the easiest way. So x1 comma x2. So when you plot, what you write, x1 plus x2 is equal to 8. This is your budget constraint because the prices are 1 comma 1. So when you plot this, you get this line. Okay, so this is the plot of the regime 0. Okay, now we move to regime 1. What does this say? the price vector in regime 1 is 1 comma 4. Okay, and the income in regime 1 is 26. Okay, so the budget constraint for this regime is x1 plus 4x2 is equal to 26. Okay, now when you plot this, let me extend this line a bit. I'm using a different color for regime 2. So x1 will be, one second. So x1 will be something 26 and x2 will be something 6 point something. And this is the budget constraint for regime 2. Okay. Now what we are being asked is determine the region of permissible choices the region for permissible choice for x1 if choices x0 and x1 are consistent with maximization of preferences that are quasi-linear in the first good. Okay, so see, understanding the question first is important. What the question means. Give me 1 second. Yeah, what does the question mean? You have to, in this graph, the commodity space graph you have to determine the permissible range for x1 such that the choices in x, the 0 regime and the 1 regime are consistent with a quasi-linear utility preference in the first good. So suppose my preferences is quasi-linear in the first good. So what do I write? How will I write that? This functional form represents that my utility function is quasi-linear in the first good. Okay, what is good about it? When you take the first order condition with respect to x1, you get 1, and when you take the first order condition with respect to x2, okay, now this is nothing but marginal utility of good 1 and this is nothing but marginal utility of good 2. So you write it in this form: mu1 by mu2 is equal to 1 divided by 1 by 2 root x2, which is nothing but 2 root x2. Okay, and we know that MRS is always is equal to the price ratio. So we have this with us. Is it fine? Okay, so now see, just let me add a page. Okay, so see what happens is the price vector in the 0 regime is 1 comma 1 and the price vector in the 1 regime is 1 comma 4. So what can we see? What can we observe from here? That good 1, sorry, good 2 is relatively more expensive in regime 2 compared to regime 1. Okay, okay, so if I take the price ratios, so see, this is p0, this represents the regime. Now p01 represents price of good 1 in regime 0 and p02 represents price of good 2 in regime 0. Similarly, p1 represents the regime and p11 and p12 represent the prices. Okay, so this is a notation thing which you have to keep in mind. So now when you, so suppose you have this. Okay, so what does this say? Price of good 1, price of good 1 in regime 0 by price of good 2 in regime 0, and that is equal to 1 by 1. And when you have P11 by P12, I'm not writing the English again, it's 1 by 4. Okay, so what you can see is P10 by P20 is greater than P11 by P21. Okay, or you can write P20 by P21 is less than, sorry, have I written this correctly? Let me check. No, this will be 1. So the relative price of good 2, uh, is this correct? P1, I'm just inverting the order. Yeah, this seems to be correct. Okay, so price of good 2 in regime 0 relative to good 1 is smaller compared to price of good 2 compared to good 1 in regime 1. This is what this equation means. This thing here. I'll write the English so that you can follow. Just give me 1 minute. Yeah, so what this equation represents is, let me write it more. So the relative price of good 2 in regime 0 is less than the relative price of good 2 in regime 1. Okay, so this is what this means. Now go again let's go back again to the diagram we had. This is not exactly 6.5, it's something 6 point. I'm just writing it for easiness. Okay, so now you see that good 2 is relatively cheaper in the zero regime. The black line represents the zero regime and the red line represents the regime 1. Okay, so what you can conclude is the consumption of good 2 in the zero regime is going to be greater than the consumption of good 2 in regime 1. Okay, so in regime 0 you already have been given what is the consumption bundle. So you see here, this is already given to you. Okay, so let's mark that. So suppose 4 comma 4. So 1 second, this line won't pass through 4 comma 4. I'll just correct it. Okay, so in regime 0, this is your choice bundle 4 comma 4 that has already been given to you. Now you are being asked in regime 1 what will be the permissible range of choices for good 1. Okay, so now see here you have to use some logic and some common sense, in the sense that you see this budget line is the frontier. By frontier I mean the extreme of what you can buy in regime 0. Okay, this represents, sorry, 1 second. Yeah, this represents what you can buy in regime 0. So this is the extreme This is the maximum you can buy. Everything inside it you can also buy. Okay. Now, this red line, which you see, which lies inside this budget set for the regime 0, is already affordable in that regime. Okay. But still, this choice was made. This choice was made given the fact that these goods were already affordable, but you still didn't choose these goods because you got more utility when you selected this one, that the the 4 comma 4 point. Okay. So when you come to regime 1, there is no point for you to select from this part. uh, 1 second, I'll just mark from this part. Okay. No, so you have this part which from which you can select, which will be giving you a higher utility. And you also have, you know that this is going to happen, that x20 is going to be greater than x21. So this is your x20 because 4 is that. So when you have this line, so x21, whatever you select, the good 2 in regime 1, the the point of the choice you make on this budget line will has to lie somewhere here, because this is the region where x20 is greater than x21. Okay, because if you would have chosen this region, then x21 would have been greater than x20, which will violate your these conditions. So in order for you to follow these conditions, you have to follow this, and this gives you a permissible range. This is that range in which you can choose x1. So this is the range of x1 which you have to choose in order for you to come to the solution for part B. So you see what the question asks. Determine the region of permissible choice of x1. I'll just mark it 1 second. Yeah. Determine the region of permissible choice for x1 if the choices x0 and x1 are consistent with preferences that are quasi-linear in respect to first good. So quasi-linearity has been used. The preferred bundle in the regime 0 that has already been given to us, which is this, that has been used. These things have been used to plot the budget lines, and then we have to come up with a range of x1, good one in the regime 1, such that, no, not just good one, both the goods, good one and good 2 in regime 1, such that this condition is satisfied, the condition that is stated in part B of the problem. And so when you solve it, you are getting that this seems to be the permissible range beneath the horizontal line that is satisfying the condition. So that is going to be my permissible range. Okay, so this is the solution to this problem. Similarly, you have to solve all the 4 parts A, C, D, E using graphs and logic. There is no maths to this problem. There is only conceptual clarity which you need to know. The regimes I have explained. There are 2 regimes, 0 and 1. The information for the 2 regimes are given to you. In the regime 1, you are being asked what should be the permissible choices for the 2 goods in regime 1 such that a few conditions are followed. Quasi-linearity in the first good was the first condition we solved for. Now there are other conditions that you are being asked. So quasi-linear with respect to second good, or consistent with maximization of preferences for which both goods are normal. So you need to know the definition of what are normal goods. Then maximization with respect to homothetic preferences. So you need to know what homothetic preferences mean and how will that be applied here. And then in the first part, you are being asked consistent with maximization of preferences. So you can try these 4 questions. This is a bit involved question. You might not reach to the correct answer completely, but give yourself time, try to solve it again and again. If you have some solution, you can WhatsApp me. I'll see and let you know if it is correct or not. Or you guys can discuss among yourself in the WhatsApp group which you must be having. So do these questions, the four questions, these are very important questions. In ISI, especially the PEA part, they try to form questions in which you have to plot graphs and look for permissible regions and exclude something which is not going to be the optima. So developing that habit from now onwards will help you in the exam very much. So I think it's a good exercise for you to carry out. So I think we are more than the time. It's nearly 2 hours. So sir, can we end? Okay, so sir is asking to end the session now. So thank you guys. Whatever reviews you have, please tell them to sir so that he can communicate to me and I can be better in the next class. This was the first class which I took. Do not use the short forms which I am using. Again, I am telling you, because these short forms won't fetch you marks in the PEB exam, especially. You have to write everything precisely and clearly. And let's meet next week. You will have a fresh problem set. Try the problems, and I encourage you all to try the problems first by yourself before coming to these sessions, because then you can ask doubts and you can understand things better, because these questions are tougher questions, the questions on the tougher end. So it's better if you try on your own and then come, because if you don't try and come, there will be many things which you won't even get a hang of. So I encourage you guys to at least try it once. Take some time and try it. Watch the lecture sir has for the relevant topics. Read the books and do try to solve the problem. That is going to help you. And this is a practice which you have to keep continuing till your exams come. So yeah, that is I'm done. If you have anything else to ask, you can ask, or else we can end this meeting. Okay, so since nobody has asked, nobody has something to ask, I'll leave the meeting. Okay, thank you.